If you remember in lecture 14, we had done about SN1, SN2 reaction, then differences between the two, and aromatic nucleophilic substitution reaction. Today we'll be doing our same series of basic organic chemistry, in which today I'll be doing aromatic electrophilic substitution reaction, in which I'll be explaining you the different types of reactions, then elimination reaction. We shall continue with our lecture. Yeah, so aromatic electrophilic substitution reaction. Substitution reaction. So what do you mean by this? Means attack of an electrophile. Whenever the electrophile attacks an aromatic ring, basically it is known as, and it displaces the hydrogen atom of the aromatic ring. If it displaces the hydrogen atom of the aromatic ring, then it is known as aromatic electrophilic substitution reaction. Basically, so what do you mean by aromatic? Displacement of hydrogen atom of the benzene ring by an electrophile is fine. Yeah. So today we'll give best example is aromatic substitution reaction of electrophilic substitution reaction of benzene. Benzene basically is very rich in electrons. Is rich in, because it contains pi bonds. It's very rich in electron. But since all the electrons are involved in resonance, therefore it is a very weak nucleophile. So, and it does not act as a nucleophilic substitute, so nucleophilic group. No. Whenever so it's very difficult to undergo a nucleophilic substitution reaction in that. So generally, a benzene ring undergoes only electrophilic substitution reaction. Suppose if there is an addition of a particular group on the double bond. Take for example. Now suppose there is a R attached to a nucleophile. Now then, if there is an addition of a nucleophile, then there will be R and here will be N. Then this is purely addition reaction. But one thing, यहाँ benzene which is a stable, and this is leading to a formation of a, this, why it is stable? Because it is aromatic. This is non-aromatic. Benzene, this is an H, when it is attacked with the nucleophile. So what happens? It will prefer plus H. That means it will displace the hydrogen atom, right? You can say by R. Since there is no loss of aromaticity, so therefore electrophilic substitution is preferred, because R is nothing else but an electrophile. R is an electrophile, so the electrophile gets attached. Now, what are the general characteristics of aromatic nucleophilic substitution reaction? First, general characteristics. Fine. Then it is given only by those compounds having a electrophilic group as a leaving group. electrophilic group as a living group. For example, hydrogen, or you can say COOH. Fine. Take for example here hydrogen, which is a electrophilic group. Now this has been displaced by an electrophile. Means a compound containing an electrophilic group like hydrogen is displaced by an electrophile. Displaced by an electrophile. This is the first criteria for it. Then secondly, we can say takes place in presence of Lewis acid like AlCl3, ZnCl2, here you can say BF3, etc. Now, take for instance this is the H and this is, you can say, RCOCl, and this will be, H will be replaced by COR. COR. Now, I'll show you how the mechanism of this particular reaction. Now what happens? First we have said RC double bond O Cl. This gets converted to first as electrophile, C double bond O plus. This is an electrophile. Then comes our benzene. Positive, here will be negative. Now this, when reacted with C double bond O R electrophile, then this will attack here. And here there is the H. Now it will positive charge. It will undergo aromaticity. So finally we will get this product. Fine. Now there are certain rearrangement reactions which lead to the formation of electrophile. Take for instance HNO3. It gives me N double bond O, coordinate bond O minus, and this is plus. This means it is NO2. Fine. Then H2SO4, which gives SO4H as the electrophile, as the SO4H as the electrophile. Then you can say CO plus HCl gives HC double bond O as the electrophile. Then you can say X2 will give X plus, which is generally used in halogenation reaction. Halogenation reaction of a hydrocarbon. Then you can say Rx plus AlCl3. It will be a formation of an R plus. So, and you can say HCN when reacted with ZnCl2. It will lead to the formation of HC double bond NH plus charge. Right? Now, just make a note of it, how the rearrangement leads to a formation of different electrophiles. These are very important electrophiles. The further reaction will come through the applications of it. Yeah. Now we will see first the mechanism. Mechanisms are very important. Mechanism, we will see the mechanism of Friedel-Crafts reaction. Friedel-Crafts reaction, right? Where benzene ring, which when reacted with an alkyl halide in presence of an anhydrous AlCl3 gives R plus HX. Now, we will see the mechanism of it. You can say first, what is the step 1? Step 1 is, suppose if I take alkyl halide as C, it initially first reacts with AlCl3, CH3, CH3 plus positive charge. Here is the electrophile formation. Then AlCl4 minus. AlCl4 minus. Right? Now the second step. So suppose if I this is positive charge, this is negative charge. Now this, when reacted with CH3, CH with the positive charge, fine, then this attacks leads to the formation of this with positive charge here. Now this hydrogen is there which undergoes aromaticity. This is CH3, this is CH3. Fine. So the first step happens to be the attack of AlCl3 on the alkyl halide, leading to formation of positively charged carbon, that is carbocation, and then AlCl4. Now the benzene ring, this is the positive charge, undergoes resonance, right? The negatively charged species attacks on the carbocation, leads to the formation of a species. Now Now, how does this, basically you can say this mechanism happen? We can say this is positively charged, this is hydrogen, and this is CH, CH3 and CH3. Now you can see AlCl4 has been formed here in the stage 1. AlCl4 minus. Now what happens? It absorbs this hydrogen and then this undergoes resonance, right? Leading to the formation of CH3, CH3 plus AlCl3 plus HCl. Fine. So ultimately we have got again the AlCl. So initially there is a formation of a AlCl4 negatively charged species, which in the second stage you can say abstracts the proton to complete the aromaticity, leading to formation of alkyl benzene. We have seen electrophilic substitution reaction. Electrophilic substitution reaction. Here the acidic hydrogen atom next to the electron deficient carbon. Electron deficient carbon atom. The acidic hydrogen atom next to the electron deficient carbon atom is replaced by an electrophile. Example, we can see halogenation. Right. Now take for instance, we can say R C double bond O dash CH2 R. This on treatment with Br twice in presence of an acid leads to the formation of RC double bond O dash C Br and R. So R dash. Now we'll see the mechanism of it. RC double bond O. I'll take the mechanism in the next slide. You can say RC double bond O dash CH2 R dash. This first is initially treated with an acid, due to which this is easily protonated. OH plus dash CH2 and R dash. Now we can say RC double bond OH. This is CH. Now this goes here and again this one here. So this will form a RC single bond O minus double bond. You can say CH dash R. CH dash R. This is nothing else but an enol formation, we can say. So it will OH double bond CHR. So this is enol. Now, this was step 1, step 2. Now step 3. In step 3, RCOH double bonded CH dash R. Now here we are getting an electrophile Br plus. How we have got Br plus? Because Br twice, which will break. One will be Br minus and other will be Br plus. So the electrophile. Now what happens? This will go here and then this will attack on Br plus electrophile. Then R C double bond O dash CH dash Br dash R dash. Fine. I'll take this R dash, and here R dash. Fine. Yeah. Now, so this. So this now again think, since another alpha hydrogen atom is there, then another bromine will come in the same fashion. The mechanism goes in the similarly as we have done in stage 1, step 1 and step 2. So it will be C Br. As in the step, this mechanism I have shown you how one bromine is attached. The similarly in the same mechanism we can see another bromine is also attached. Fine. Now we'll go by another reaction which is known as elimination reaction. What basically you mean by elimination reaction? Elimination reaction is nothing else but a removal of one or two atoms or groups from a molecule. Removal of one or two atoms or groups from a particular molecule, which basically you can say leads to a formation of a species, like you can say carbene type, या फिर geminal dihalide, vicinal dihalide, and then even a double bonded compound basically is known as elimination reaction. So there are, so what do you mean? Loss of one or two group or atoms leading to formation of, can say, geminal or vicinal dihalide, or you can say a double bonded compound, or you can say a halocarbene. No. There are two types of elimination reaction. First one is alpha elimination, or it is also told as 1-1 elimination reaction. And the second one is beta or 1-2 elimination reaction. Beta or 1-2 elimination reaction. Now, we'll go in detail about alpha elimination. What do you mean exactly by alpha elimination reaction? Now, here a group or atoms are generally removed from the alpha carbon atom. Group or atoms are generally removed from the alpha carbon atom. Take for instance, which is alpha carbon atom to the nucleophile. Alpha carbon atom to the nucleophile. Take for instance, we can say chloroform type CHX3. Fine. This on treatment with a alcoholic QH, because this is an acidic proton. So we will find CX3 formation of a, this is known as a halocarbene. Fine. Now, similarly, we will see beta elimination reaction. Now, basically, beta elimination is nothing else but, I'll give you an example: CH3, CH2, CH2 bonded to a leaving group. LG, leaving group. Fine. So this is the alpha carbon atom, this is the beta carbon atom. That means this alkane attached to an alkyl group attached to a living group which contains alpha carbon atom and beta carbon atom both. So you can say removal of this alpha hydrogen atom, removal of this alpha hydrogen atom, removal of this beta hydrogen atom to be more precise, not alpha. Alpha is in the previous case. This is a beta elimination reaction. So I can say if I remove a beta hydrogen atom CH, then double bond CH2 plus the leaving group will be minus and an H. Fine. So a beta hydrogen atom is removed, leading to the formation of an double bonded unsaturated product. Double bonded unsaturated product is known as beta elimination reaction. No. Thus we can say there is a removal of a leaving group from alpha carbon atom and loss of hydrogen from an beta carbon atom. Removal of living group from an alpha carbon atom and loss of hydrogen from a beta carbon atom, leading to that, or we can also say a loss of one sigma bond and formation of one pi bond. And this basically is known as beta elimination reaction. So loss of one pi bond, one sigma bond, and formation of a pi bond is known as this. Now there are different types of beta elimination reaction. First one is E1 reaction. Second is E2 elimination reaction. And third is E1CB elimination reaction. E1CB. Now we'll see all the three reactions one by one. First one is E1 reaction, or you can also say it is a unimolecular. As we have seen in SN1 reaction, which is a unimolecular, that means the rate of the reaction, you can say the rate of the reaction depends upon only one factor, one parameter, one of the parameter. So it is known as unimolecular reaction. Take for instance, I will take a tertiary alkyl halide. Any X, suppose this is a very good leaving group. So what will happen? Leading to a formation of a carbocation, yeah. Leading to a formation of a carbocation. Now, this is the step one. I'll go to the next slide. E1 reaction. There is a plus no, or you can take it in a more precise manner. Take for instance CH2 dash C dash CH3 dash CH3. It's positive. Now what happens? A nucleophile OET that absorbs this hydrogen atom, right? And then this will go and So CH2 double bond C, here CH3 and here CH3, leading to the formation of E2OH, that is ethanol. Fine. A nucleophile abstracts a proton, attacks on the proton. That means you can say a nucleophile or a base. This is basically a base. Base attacks this acidic proton. Base attacks the acidic proton, and this shifting of this bond to give me a double bond. Fine. So this is a elimination reaction from the, because the this is beta carbon atom. This is the this is the beta carbon atom. CH2H dash C, CH3, CH3, a positive charge, and here there is a base. Take for example ethoxide. This abstracts the proton, then this goes here. So this is the alpha hydrogen atom, CH2 double bond C gives me CH3 and CH3. So this is a double bonded compound, plus leading to the formation of ethanol. Now here the rate of the reaction is directly proportional to the substrate only. Therefore it is a unimolecular. Now E2 reaction. Now what do you mean by E2 reaction? In E2 reaction, it is also somewhat similar. CH2, this is H, CH, this is CH2X. Now this on treatment with some base, again the same thing. The base will abstract a proton. This, in this case it was the alpha, and here it is abstracting from the beta. Fine. Then this will go here, RCH double bond CH2 plus the base. Right. So this is the E2 reaction. It is undergoing from the beta hydrogen atom. The base is removing from the beta hydrogen atom. In this case, the base was removing from the alpha hydrogen atom. So here the rate of reaction is directly proportional to the substrate and the base. Why? Because the substrate, because the leaving group has to be a good leaving group, plus base has to be strong, so as to it can easily remove the beta hydrogen atom, because beta hydrogen atom is not as acidic as alpha hydrogen atom. So you will require a stronger base. Stronger base is there, and now since it is from the beta hydrogen atom, so the leaving group also has to be a good leaving group. So basically you can say it is dependent on both the substrate, that is alkyl halide, and on the base. Fine. So that is known as the second E2 reaction. Third, E1 CB reaction. Here what happens here, the acidic hydrogen atom. Here the acidic hydrogen atom is removed by the base. Here the acidic hydrogen atom is removed by the base to give a carbonyl. See. Now CF3 dash CHCl2. Suppose now this is the ethoxide. Now this is the alpha carbon atom, this is the beta carbon. So the now this will contain then it will take CF2 dash double bond CHCl. So how this basically reaction will go? CF3 dash C, this is H, this is Cl, this is Cl, now plus ethoxide, once it goes here, then this will go. So that means the first step happens to be CH3C, take for example Cl, and then minus charge. So there is a formation of a carbon atom. There is a formation of a carbon atom. Now you can say Cl. This is minus charge. Sorry, this is, wait a minute, this CF2 and this is F, C, Cl, and this is negative charge. So this will happen here and this will be a leaving group. So it will be CF2 double bond Cl twice. That means we can say in even CB reaction which leads to the formation. Why? Because there is a removal of hydrogen atom from the alpha carbon atom, and plus the beta carbon atom should contain any good electronegative element, or you can say it should have a good leaving group also. So it should be an electronegative element or a good leaving group. Now, so fluorine happens to be on the beta hydrogen atom. So whenever there is the carbon and where the negative charge becomes a double bond, obviously there is a leaving group of fluorine which goes off. So leads to the formation of CF2 Cl2. So this is so I think so you might have understood it completely. So you please share this video with your friends, and I'll meet you in the next lecture, lecture 16, in which I will be teaching you or other different types of reactions. As today we have seen two types of reaction, more reactions we will see in the next lecture. Then I do request you to please just subscribe my video, and if you're looking at YouTube, and if on Facebook you do, please follow it. My required websites and this queries for I have given my link. You can follow me on Instagram, on Facebook, and you can write me on WhatsApp also, which I have mentioned on everything in my description box. Okay, thank you, thanks a lot, namaskar.